This video is about math induction for inequalities. N factorial greater than 4 to the nth power, n greater than or equal to 9. Normally, we always put exponential form first. So we want to prove 4 to the nth power less than n factorial for n greater than or equal to 9. We will use a CAP method, check, assume, prove. Check it's true for n equals 9. Please check the domain. N is greater than or equal to 9. 4 to the 9th power equals, and 9 factorial equals. It's true. Second step, assume it's true for n equals k, which is 4 to the kth power less than k factorial. You have to write down the domain for k. K is greater than or equal to 9. We want to prove it's true for n equals k plus 1, which is 4 to the power of k plus 1 less than k plus 1 factorial, k greater than or equal to 9. Then we will prove from left to the right. 4 to the power of k plus 1. Remember, we need to create this 4 to the kth power first, so that we can use this assumption. 4 to the kth power times 4 to the first power. Now we can use this assumption, less than k factorial times 4. This is our thinking part. We want to prove 4 to the power of k plus 1 less than k plus 1 factorial. We already got 4 to the power of k plus 1 less than k factorial times 4. So, as long as we can prove k factorial times 4 less than k plus 1 factorial, k factorial times 4 less than k factorial times k plus 1. Then we divided by k factorial both sides. Reduce 4 less than k plus 1. Since k is greater than or equal to 9, this is always true. Then you need to write down this inequality from bottom to the top, because 4 less than k plus 1, we are given k greater than or equal to 9. Backwards, so we times k factorial both sides. K factorial times 4 less than k factorial times k plus 1. So we got k factorial times 4 less than k plus 1 factorial. So 4 to the power of k plus 1 less than k plus 1 factorial for k greater than or equal to 9. Therefore, 4 to the nth power less than n factorial for n greater than or equal to 9. When you prove inequality, you have to pay more attention to the domain. Question 18. 9n less than 3 to the nth power n greater than equal to 4. Normally we put the exponential form first. because it's easier to prove. Check is true for n equals 4. 3 to the 4th power equals 81. 9 times 4 equals 36. So 81 greater than 36. It's true. Second step, assume it's true for n equals k, which is 3 to the k's power greater than 9k. Do not forget the domain k greater than or equal to 4. We want to prove it's true for n equals k plus 1, which is 3 to the power of k plus 1 greater than 9 times k plus 1 for k greater than or equal to 4. We will prove from left side to the right side. 3 to the power of k plus 1 equals. We want to create 3 to the k's power so that we can use this assumption. 3 to the k's power times 3 to the first power. Use this assumption. Greater than 9k times 3. Simplify equals 27k. Now let's go to thinking part. We already proved 3 to the power of k plus 1 greater than 27k. We want to prove 3 to the power of k plus 1 greater than 9 times k plus 1. We just need to prove 27k greater than 9 times k plus 1. Simplify 27k greater than 9k plus 9. Minus 9k both sides. We got 18k greater than 9. Then you divide it by 18 both sides. K greater than 1 over 2. This is true. We will write down this thinking part from bottom to the top. Because k greater than 1/2. This is reason. Domain k greater than or equal to 4. Then we times 18 both sides. 18k greater than 1/2 times 18 is 9. Then we need to add 9k both sides. 9k plus 18k greater than 9k plus 9. So we got 27k greater than 9 times k plus 1. So 3 to the power of k plus 1 greater than 9 times k plus 1. Therefore, 3 to the nth power greater than 9n for n greater than or equal to 4. 22 to the nth power greater than 10n plus 7 for n greater than or equal to 10. Since this inequality starts with the exponential form, we just leave as it is. Check is true for n equals 10. 2 to the 10th power equals 1024. 10 times 10 plus 7 equals 107. So it's true for n equals 10. Assume it's true for n equals k, which is 2 to the k's power greater than 10k plus 7 for k greater than or equal to 10. We want to prove is true for n equals k plus 1. 2 to the power of k plus 1 greater than 10 times k plus 1 plus 7. Let's start with the left side. 2 to the power of k plus 1 equals 2 to the k's power times 2. So that we can use this assumption. It's greater than 10k plus 7 times 2. Simplify 20k plus 14. Thinking part. We want to prove 2 to the power of k plus 1 greater than 10 times k plus 1 plus 7. We already got 2 to the k plus 1th power greater than 20k plus 14. We just need to prove 20k plus 14 greater than 10 times k plus 1 plus 7. Simplify both sides. 20k plus 14 greater than 10k plus 10 plus 7. Write down the inequality in detail. 20k plus 14 greater than 10k plus 17. Then we minus 10k both sides. 10k plus 14 greater than 17. Minus 14 both sides. 10k greater than 3. Then divided by 10 both sides. K greater than 0.3. This is true because this k greater than or equal to 10. Then we will write down our proof from bottom to the top. Because k greater than 0.3 given k greater than or equal to 10. Then times 10 both sides. 10k greater than 3. 10k greater than, this 3 we will change into 17 minus 14. This 10k we will change into 20k minus 10k greater than 17 minus 14. Add 14 both sides. 20k plus 14. At the same time, we add 10k both sides. 10k plus 17. Then we will change this 17 into 10 plus 7. So we got 20k plus 14 greater than, take a 10 out. 10 times k plus 1 plus 7. So 2 to the power of k plus 1 greater than 10 times k plus 1 plus 7. Therefore, 2 to the nth power greater than 10n plus 7 for n greater than or equal to 10.